This factory in Taiwan makes 400,000 computer motherboards a month, and amazingly, a lot of the work is still done by hand.
Gigabyte's Nanping factory, about 45 minutes west of Taipei, is the only motherboard factory left in Taiwan. 1,200 employees work here, installing, assembling, checking and packaging motherboards before they're sent out to stores. And it all begins here on the 7th floor with these machines that print solder paste onto the base circuit board. The board then passes through this series of robots that put components in place. Tiny resistors and capacitors, each about the size of a grain of rice, are fed from these reels, and factory workers need to keep a constant eye to ensure they don't run out. If that happens, the production line would stop. Next is a run through an oven that melts the solder so the components become attached to the board.
This machine behind me is doing optical checking of the boards. It takes photographs and compares those against a database to make sure that every component is where it should be.
Gigabyte has 10 of these production lines, and they all end up with a final check by eye before the board is off to the 5th floor. And on the 5th floor, boards begin with another robot, but robots can only do so much.
This is where a lot of the manual work begins. On this line behind me, circuit boards are continuously moving along, and these people are checking the boards and attaching individual components.
While tiny components can be automatically placed, larger components like some capacitors, memory sockets and audio connectors are done by hand. Each operator at each workstation is responsible for a number of components, and they need to work fast to keep the line going. All the while, a robot scoots around the floor behind them, delivering components so they don't run out. And at the end of the line, there's another soldering process and series of checks before the board goes down again, this time to the 2nd floor. And it's here where the packaging process begins. Machines punch out boxes and operators add accessories like cables and put the boards in bags to prevent damage. The driver disc and manual are added, and then the boards are put into their boxes. Throughout the process, everything is scanned to ensure that the correct components are going with the correct motherboards.
And at the end of this line, as all of the components are put into boxes, this is what we end up with: piles of motherboards ready to ship out.
The Nanping factory accounts for about a quarter of Gigabyte's motherboard production. And on this line and others in this factory and elsewhere, boxes of motherboards are continually produced, eventually ending up in PCs around the world. And that's how a motherboard is made.
Let our experts walk you through the nanocosmos of the atom. A world that normally remains hidden from our eyes. In the beginning is the circuit diagram. At design centers around the globe, experts collaborate to design circuit diagrams, sophisticated integrated circuits like microprocessors, high graphic processors, and wireless communications ICs. The next step is manufacturing. The disk substrates for the microchips are made from quartz sand and are called silicon wafers. To make these wafers, a huge monocrystal is drawn from purified silicon melt. The result is a perfect silicon lattice into which the transistors will later be fitted. However, impurities pose a threat to these flawless silicon crystals. Our GlobalFoundries manufacturers must therefore take extensive precautions every time they enter our dust-free clean rooms. The result? Our wafers are fabricated in an environment that is more than 100,000 times cleaner than an operating theater. Completely free of dust, the silicon discs arrive at the clean room. Here, 25 wafers are packed into each hermetically sealed container and sent off on a journey that will take them through hundreds of manufacturing steps. Photolithographic techniques transfer the circuit structures to the wafers, rather like slide projection. The key to this whole process is a solid mastery of light. The silicon disc is spin-coated with a photosensitive resist. UV light transfers the circuit structures depicted on a mask to the wafer. The exposed parts of the resist are soluble and are removed by a developer. The transferred structures can now be used as a template. The unprotected parts of the water surface are etched away. The structures of billions of small current switches are generated on each wafer, tiny transistors. From the photolithographic stage, wafers move on to the ion implantation, where the electrical properties of the transistors will be specified. Here, the engineers make good use of one of silicon's most important properties. Silicon is a semiconductor, which means that its conductivity can change via a high precision emplacement of so-called dopant atoms. First, dopant atoms are injected into the silicon structures. These atoms then distribute randomly in the silicon lattice. At high temperatures, the doping atoms become flexible and take on a fixed position in the atomic structure. The complexity of manufacturing tiny transistors requires a clean room as big as 2 soccer pitches. While our people monitor the complex processes, automated manufacturing itself always takes place within hermetically sealed production lines. Copper dominates the next process step. The finest interconnect wires link up billions of separate transistors to form integrated circuits. Before that can happen, however, cleaning is essential for wafers, as particles lurk at every stage in the manufacturing process. Before the copper is poured into the trenches for the interconnects, a barrier layer is applied. It helps to avoid short circuits and guarantees reliability. The trenches are then filled with copper. Finally, the excess copper is ground down to the edges of the trenches. This insulates each interconnect from the others. A microchip made of copper wiring established GlobalFoundries as the first company in the world to adopt copper in volume production. A foundation for the state-of-the-art multi-core processors that GlobalFoundries is introducing today in all product areas. To keep us on the leading edge of the world's chip makers, electron microscopes constantly monitor every step